Okay, these notes are going to go through the remaining two properties for division that we have not covered. We've covered 5 of them right now, and we have 2 more left to cover to make a grand total of 7. All right, so these are your division properties of exponents. The first one is known as the quotient of powers property. Remember, quotient means division, so it makes sense as to why these are division properties. So this property right here says that to divide powers with the same base, you are going to subtract the exponents. Okay, remember in multiplication, the property we had for that one said you would add the exponents. So since multiplication and division are opposites, then instead of adding, you're going to subtract because those are opposites. All right, so the examples I'm going to show you are going to demonstrate what this property is about. All right, so the first one is 6 to the 5th power divided by 6 to the 4th power. Now the way this property came about and why this property came about, I'm going to show you the long reason behind it, but then we'll use the shortened version because it's meant to be shorter. The first one, 6 to the 5th power, is 6 times 6 times 6 times 6 times 6 if you had to write it all out. The bottom would be 6 times 6 times 6 times 6. And in division, a 6 divided by a 6 makes a 1, so we cancel them out. So if I cancel out a top 6 and a bottom 6, I'm left over with 1/6 as my final answer. Right? So now if I use this property that says just subtract the exponents, my base is a 6, and when I subtract 5 minus 4, I get a power of 1, and 6 to the 1st power is 6. So you're going to get the same answer, it's just that it's shorter and faster. That's the beauty of these properties, that it allows you to do that. Right? You no longer have to write out the long stretched out version. Use the property and your answer comes to you very quickly. Right? So that's what we're doing with this property, is we're subtracting those exponents. Okay, so for the next one, if I have in parentheses -5 squared divided by parentheses -5 squared, okay, my base is -5 in parentheses, and then if I use the property trick of subtracting exponents, 2 minus 2 gives me 0, which is another property that you now know. Anything to the 0 power is 1, so your answer to that one is 1. Okay, for the next one, you're going to have to do a combination of sorts. If you have 9 to the 4th power times 9 to the 2nd power, all up top, over top of 9 to the 7th power. You cannot do any kind of subtraction until you combine the top ones together. So this is where you use your multiplication property before you do your division property. So if we put the 4 9s at the top with the 2 9s at the top, we have 9 to the 6th power. We still have 7 9s at the bottom. Now you can do the property of 6 minus 7 giving you a -1 and then make it happy. So let me show you what that looks like. You have 9 to the -1, and we know that that's over 1, and to make it happy we get 1/9. There's a shorter way. If you notice the 6 and the 7, you notice you have more 7s on the bottom, or sorry, more 9s on the bottom since there's 7 of them, than you do on the top. So if I take all of the 9s from the top away and I take those 6 away from those 7, I'm still left with a 9 on the bottom. So if you think like that and you use that, you're going to jump to the answer without having to do this in-between step. Right, so I'm going to try and get you to think like that because it does create more work if you do the negative exponent business. But if you can't get your thinking to work the way you want it to, you've got a backup plan. Right, so let's look at another one that does that same sort of thinking. If I have 1 over y to the 5th power times y to the 3rd power, you can't continue this until you put the two problems together. Y to the 3rd is a fraction over 1. You multiply straight across, you get y to the 3rd power over y to the 5th power. Right? If you go to subtract, you will end up with a negative exponent, then you'll have to make it happy. But let's try the other trick I just showed you. You have 3 y's on top and 5 y's on the bottom. Because the largest amount is on the bottom, your leftovers are going to be on the bottom. So you take the 3 from the top and steal those 3 off the 5, and that leaves you with 2 still on the bottom. Now that you've taken all the top ones away, you have to hold the spot with a 1. So this is your final answer, but you didn't have to do any extra steps. You just had to think a little differently. Wherever your largest amount of a letter or number is, that's where the location of the answer will remain. All right, so now let's go to the last property for this unit, and it is known as the power of a quotient property. And we've already done this one in a way. I've managed to sneak it into some of our other examples without calling it this. So you're going to recognize pieces of this one, right? But then we're going to do some more with it. Right, so here's what this property says. To find a power of a quotient, you are going to find the power of the numerator and the power of the denominator, and divide. Or simplify, depending on what's left. Okay. This is very similar to the distributing property. Instead of distributing an exponent to a product, you're distributing a power to a quotient. Right? So that's why you're going to recognize some of these, because quotients are really fractions, and I've already shown you how to distribute to a fraction. Right? So for the first example, if I give you 2/3, that's a quotient, 2 divided by 3, but we're going to square it. So what this property says is that that power on the outside has to give to the numerator and give to the denominator. So this really makes 2 squared over 3 squared, which turns into 4 over 9. So your answer is 4 over 9. I've shown that to you in class. We've done a couple of those, so this should look familiar. And so that's number 1. Number 2, if I give you -3 divided by y as your fraction, raised to the 3rd power, you have to give that power of 3 to top and bottom. Right, but because the top number is a negative number, when you give it to that one, you've got to keep the -3 in parentheses or you mess things up. And then on the bottom, when you give it to the y, it just stays y to the 3rd power. Okay, you cannot leave powers in fractions. Your numbers have to convert to a regular number. So -3 in parentheses to the 3rd power is -27, and y to the 3rd power just stays y to the 3rd power. So here's your final answer. Okay, remember, no powers left in fractions or as coefficients. Right. For a third example, I give you 7 divided by 4, and this time it's raised to the -3 power. So now we're incorporating the negative exponents. You still want to take and give it to them, each one top and bottom. Okay, so that's 7 to the -3 over 4 to the -3. Neither one of them are happy, so flip it. So that becomes 4 to the 3rd power over 7 to the 3rd power, and get rid of those powers, make them actual numbers. So 4 to the 3rd power is 64. And 7 to the 3rd power is 343. This fraction cannot be reduced, so it's done. If it can be reduced, you need to keep going. Okay, and then one more example under this category, and then we'll try to put all this stuff together. Right, for the fourth one, 15 over 3 in parentheses squared. Now, there is a long way through this one, and there is a short one. The short one takes less than a minute to do. The long way takes a couple minutes to do. So you decide which one you want to do, but you got to be able to see it beforehand. If this is a division problem in parentheses, always check to see if you can reduce it or simplify it first before you start applying that exponent. I know that I can do 15 divided by 3 and get 5. So now that I know that, I've reduced it and simplified it to 5, and I'm going to bring the square down. 5 squared is 25. That takes 2 seconds to do. Right? If you distribute the squared to everybody and then divide at the end, you'll still get the same answer. It just takes you 2 times and 3 times as long as somebody else who did it the other way. So look for those little shortcuts if you can find them. All right, now the last examples that I'm going to do with you, I've got 3 of them, are going to put all exponent rules together, which means you're going to have more than 2 or 3 of them in the same problem. I do not believe that I've got an example that has all 7 of them in there, although it's not hard to make one. But the examples that I'm giving you here do not have all 7. Okay, they might have 4 or 5 of them, but they don't have all 7. All right, so here's what the first one's going to look like. This is where you're expected to be by the end of this chapter, after we get done with you. 2x squared y over 3x times 9xy squared over y to the 4th. All right, so the first thing you always look for is, do you have anything to distribute? The answer to that would be no. Then you look for your unhappy exponents. I don't have any, so I don't have that to do. So then you want to take a look at combining these fractions together, right? And the way we do that is by going straight across, because if you can combine them together, then it's a lot easier to simplify at the end. If you try to simplify now, it's going to be a little bit messy and you probably are going to forget something. So if we multiply straight across, 2 times 9 gives me 18. Remember, you multiply your coefficients. Then if I combine my x's, I have 2 x's on the left and 1 x on the right. That gives me a grand total of 3 x's on the top. Then I have 1 y and 2 y's, so that's 3 y's on the top. There's my new numerator. For the bottom, I'm going to do the same thing. I only have a coefficient of 3, so keep the 3. I have 1 x and I have 4 y's. So here's my new problem. Now I need to simplify this fraction. Right? With 18 over 3, this is just a division problem. 18 divided by 3 is 6, and here's how you know where you put your number. Wherever the largest one is, that's where the final answer goes. 18 is biggest, so my 6 is going to stay up top. Then go to your x's. You've got 3 of them on top and 1 of them on the bottom, right? So if you do 3 minus 1, you get 2. Or if you think about it this way, you steal the 1 off the bottom from the top, and that reduces the top by 1. So now you've got x squared at the top, right? Then go to your y's. You've got 3 y's on top and 4 y's on the bottom. So because the majority are on the bottom, the extras are going to stay on the bottom. And if you steal the 3 from the top and take away from the 4, you're left with 1. So there's y to the first power. This is the final answer to that problem, and it incorporated 2 or 3 of the properties. It didn't have a whole lot of them in there, but it did incorporate quite a few of them. All right, so let's take a look at a second one. If I have in parentheses 2x divided by y squared, close your parentheses, all raised to the 4th power. This is one problem, but it incorporates many properties within it. Right, so the first thing we need to look for is, do we have any distributing to do? Yes, we do. Everybody inside needs to be given the power of 4. Right, so that means the 2 gets it, the x gets it, and the y squared gets it. So here's what it's going to look like on the other side. 2 to the 4th power, x to the 4th power, and on the bottom this is power of a power, so you'll have y to the 8th power. Now, the only thing wrong with this problem is you are not allowed to give me a power in the coefficient spot. So we got to turn that into a regular number. And when we do that, we get 16 x to the 4th power, y to the 8th power. There's nothing else to do because my x and my y are different letters, and so it's as simplified as it's going to get. Here's your final answer. All right, the last one, save the best for last. He's going to take up some space on your paper. All right. But if we do this in steps, you will see that you can safely handle anything that looks as good or bad as what I'm getting ready to show you. Make sure you copy it down correctly, because that would be a major mistake if you didn't copy it down the way it's supposed to be. Okay, here's what this one looks like. And this is about as ugly as I will ever give you, right? But it's not that difficult to do if you take it one property at a time. The first property I'm going to attack is the distributing. I am going to distribute whatever power's on the outside to everything inside. Okay, so this -2 is going to go to every piece of the top and every piece of the bottom. So that means it's going to be 2 to the -2, x to the -2. Y to the +4, because it's power of a power, -2 times -2 is +4. Then y to the -8. Then I'm going to go to the bottom and do the same thing. 3 to the -2. X to the +2, because -1 times -2 is +2. And y to the -2. That first fraction has been distributed. We'll mess with it again in a minute. Go to the other one and distribute your power of 2 to everybody in that one. So this is where you end up with 4 squared, x squared, y squared. And then on the bottom, you end up with 2 squared, x to the -2, and y to the -6. Now, at this part of the problem, or at this phase in the game, however you want to look at it, we want to take and start making things happy, right? Because that way we don't have to worry about negatives and positives and all those crazy things, right? So you're going to join them, right? And when we join them, things are going to shift around. So in my fraction, I'm going to go ahead and set up my fraction bar. I'm just going to start shifting things. This 2 to the -2 up top doesn't want to be there. It's going to come down below and become a 4. 2 squared is 4. The x to the -2 doesn't want to be there. He's going to go to the bottom and become x squared. The y to the 4 is going to stay up there. It's happy where it is. But the y to the -8 next to it doesn't want to be there. So it's going to go to the bottom and be y8. The bottom level, 3 to the -2, doesn't like to be down there. He's going to come up top and be 3 squared, which is 9. Okay, the x squared on the bottom stays down there. He's happy there. The y to the -2 does not want to stay down there. He comes up to the top. So you've now made that first fraction happy. We'll deal with cleaning it up a little bit more in a minute. You go to the next fraction and do the same thing. Okay, so the top level, back up here, is perfectly happy the way it is. So I'm going to go ahead and turn 4 squared into a number so that it's nice. That's going to be 16, x squared, y squared. The bottom, some of it's happy, but some of it's not. The 2 squared is happy, but I want to turn that into a 4. This x to the -2 is going to go to the top, and the y to the -6 is going to go to the top. So this one looks very top heavy, but it won't by the time we get on with it. Now you have 2 options. You can multiply straight across and start combining and condensing that way, okay, which I highly recommend. Or you can take and start slashing things diagonally. All right, I'm going to go straight across. That way it's easier to see what's happening. Okay, but you can reduce diagonally. Okay, so if I have my straight across version, 9 times 16, okay, is going to be a large number. Okay, if you want to go ahead and get that, you can, right? Otherwise, you can go ahead and pay attention to what I'm getting ready to do next. Before I actually go straight across, I should be able to clean up some of these. There's too many x's and y's sitting around. So let's leave 9 and 4 alone. These y's right here, we can combine and make y6. That's a lot shorter looking. Okay, the bottom, these x's can go together. That makes x to the 4th and y to the 8th. Notice how short and condensed that looks compared to what it started with. Then go over here to the second one and do the same thing. The top is still going to have 16. There's x squared and x squared, which makes x4. And then there's y squared and y to the 6th, which makes y to the 8th. And then on the bottom, I just have a 4 hanging out. Now here's where the little diagonal trick comes in. You can reduce vertically and diagonally, but you cannot reduce horizontally. Okay, so over here to the left, make that a little note for yourself. Terms, diagonal, and vertically, or and vertical, can cancel or reduce. Oops. So you don't have to just go up and down. You can go diagonally. And here's what I mean by that. If I look diagonally to the 4 and the 16, the 4 can go into the 16. So 4 divided by 4 will leave me with a 1. 16 divided by 4 will leave me with a 4. Then if you look diagonally, I have x4 and x4. Those will cross each other out because they cancel out. And then I have y8 and y8 diagonal from each other. Those cross each other out too. Okay, and then if I go the other direction, 9 and 4 you can't do anything with, and then the y6 you can't do anything with. So now you can go straight across with your multiplication. 9 times 4, okay, actually there's one other thing we can do. Remember, we can cancel vertically. I couldn't do anything with the 9 and the 4, but I have a 4 over a 4, and that can cancel because that makes 1. So 4 divided by 4 crosses off. So now I can go straight across and my answer is even better. I have a 9 and a y to the 6 on the top. I have nothing left on the bottom except for a 1, so I don't even need to put it. After all that big mess you started with, this is the final answer. Okay, there is more than one way to get to this answer, and you can take multiple steps to do it. The trick is to get to the right answer at the end, no matter how you go about doing it. So just take one property at a time, know what you're doing and know that you're doing it right, and then when you get to the end, if you've done everything the way you're supposed to have, then the answer will end up the same. Okay, so we're going to keep practicing with this, but you have now learned all 7 properties that are in this unit that you will be tested on very shortly.